Yes, start now. Hi, everyone. Hi, grade 7. Three, two, one. Hi, grade 7. Welcome to this revision class. Hi, grade 7. Please have something to jot down on, because I'll be asking you to jot down some things, and you need to do that because we are revising for our assessments. Welcome to this class. This is a class we missed on Friday because of connectivity, and we're trying to make the most of today. Okay, I hope we achieve that. What we're going to do today is simple mechanisms, levers, using pneumatics, and hydraulics will be doing force transfer between syringes. This is the work that you did in term 1, and it's just a revision just to help you prepare yourselves for the coming assessments. Okay, it's part of mechanical systems and control. Okay, look carefully at the questions and answers because they may appear in your assessments. Let us look at levers. Levers have classes. We have these classes being determined by the position of these three things. Now, I want you to note this and remember it. Sometimes it becomes very difficult to identify the class of levers. Now, when you look at this, you have three components of a lever. You have effort, that's your input. Effort, stroke, input. You have your fulcrum. The fulcrum is also called the pivot, P-I-V-O-T. The fulcrum is also called the pivot. So you have your fulcrum here, you have your effort here, and you have your load, okay? This makes you think of a seesaw. In the playgrounds, you have a seesaw. We all know the seesaw. The seesaw has a ramp, not a ramp, has this beam that you sit on, which is moving on the fulcrum or the pivot. It is being moved by weight, okay? So this is a first-class lever. How do we know it? The fulcrum is between the effort and the load. Then it's a first-class lever. Second-class lever, you have your effort this way, and you have your load here, and you have your fulcrum here. If I want to lift this load, I push the lever upwards, and then I lift the load. The fulcrum is at the end of the lever. So this is your second-class lever. Between the effort and the fulcrum is your load. Then you have another type of lever, the third-class lever. You have your fulcrum here, and between your fulcrum and your load, you have your effort here. You have your effort here. So between the fulcrum and the load is your effort. Now I want you to write down FLE, flay. Flay will help you remember the classes of levers. Flay is just saying what is in the middle of the lever in the different classes. First class, you have fulcrum, F. Second class, you have load. Third class, you have effort, and that's your flay. Will you forget the classes of levers? Surely no one will forget them. If you forget them, just tell me. Tell me, ma'am, I'll forget the classes. Okay. Now, those are the classes of levers. What is effort? Every time we speak of effort, you must remember that effort is what you do. That's why we have this little fellow here. Effort is your input, what you do as a person. It's what the person does. That is the effort. And the load is what gives resistance. So if this fellow could let go of this lever, it would go down because there's resistance. The load is here, okay? So effort is the input of the system. Now, we know the classes of levers. We must now think, where do we see these levers in our everyday life? Okay? Where do we see these levers in our everyday life? Right. Now, this one is a first class lever. There is a fulcrum in the middle there. Okay, so this is a first class lever. Now, when you are extracting a nail from a plank using the claw hammer, you have your fulcrum there in the middle, and you have your effort there, and you have your load. The load is what you are working on, which is the nail. Okay, the effort is, imagine the little fellow pulling this hammer, trying to extract the nail. So that's a first class lever. Pliers. I want you to note this about pliers. Pliers and scissors. Scissors are a combination of two levers joined here on the fulcrum, because you need both the parts for this pliers to work. It doesn't work maybe as a single lever. So pliers and scissors are examples of double levers, okay, but of first class. As a tool, it is a lever system of first class. Right. Second class, we have an example of a wheelbarrow. Okay. Let us look at the fulcrum. Here is the fulcrum. Here is the load. And here is the effort. The nutcracker, here is the fulcrum. Here is the load. Here is the effort. So the load is in the middle. Now, third class. Third class, they made an example of a human arm. But when I look at this, the example of a human arm, it does look like a class 1 lever, because you have your fulcrum, the effort, and the load. So I would say this belongs there. Okay, sugar tongs. Yes, the effort is here. That is where you press to hold this lump of sugar. Okay, so this is the fulcrum. You have your effort here in the middle. Okay, so there are many other examples. Another example I can give you, when we're done with this lesson, look at the pedal bin in your house. That is a combination of many lever systems. They are joined by what we call linkages. So it's a levers and linkage system. The pedal itself, when you press with your foot on the pedal, it goes it takes the motion through a linkage to lift the lid. So those are levers. I want you to just take your time, analyze the levers and classify them on your pedal bin. Tell me, maybe at a later stage, what the pedal bin is made of, what class of levers. Identify them. Okay, now here are the questions. What is the point around which a lever turns? I want you to chat with me. Tell me. What is the point around which a lever turns? What do you call it? I even gave you the spelling. What do you call the point at which a lever turns? Have you forgotten? Fulcrum. Another name for fulcrum is? Another name for fulcrum is what? Fulcrum pivot. P-I-V-O-T. Pivot. But at least you did remember fulcrum. What is the force applied on the lever? What do you call the force that you apply on the lever? Where the little fellow stands, what do you call that? Effort. Yes, that's the effort. Okay. What is needed to lift up the arm of a lever? I want you to jot your answer down. We'll come back to it. In each of the cases below, state which class of lever. State which class each lever belongs to. Okay. This one, jot down your answer. Just jot down your answer on your scrap paper that you have. Okay. Which class is this lever? Look at this lever too. Which class is it? And this lever, jot down your answer. Which class is it? Then we fill in the blanks. I want you to jot down on your paper that you have with you there. It is easier to lift something heavy when using a lever. So we say a lever provides advantage. The purpose of this is to make work. Another name for a fulcrum is I gave you the name. Twice I gave you. Then describe 3 ways in which levers make your life easier. For 6 marks. Okay. I'm going to keep this screen standing like that so that you can jot down your answers. Then I will give you the correct answers so that you can check the correct answers against your answers. Tell me when you're done. Done? All right, let's see. Look at your answers. 1.1.1. Fulcrum, effort, load. The classes of levers, the first one was a first class lever. Why? Because you have your fulcrum in the middle. Then the second one was a second class lever. The third one was a third class lever. Then let's go to this sentence. Fill the blanks. It is easier to lift something when we use a lever. So we say a lever provides mechanical advantage. The purpose of this is to make work easier. Another name for fulcrum is a pivot. Okay. Then describe 3 ways in which levers make your life easier. Now here I can take quite a variety of correct answers as long as they make technological sense. Levers help people lift heavy objects or push and pull things. Levers are able to crush on something like the nutcracker that you saw. Levers are used in the human body. Bones in our arms and legs act as levers. You saw the example of the arm. Okay. Even your knee is a pivot. Your leg is a lever system also. We do have levers in our bodies, especially at the joints, okay, where the joint itself will be used as a pivot, right? Now tell me, did you understand levers? Are we together? Okay, no issues, no problems. Then we go into pneumatics and hydraulics. It's a revision. You did this too in term 1. Yes, thank you, Sbu. Remember, you did this in class. Now I have a question for you. What do you call these things? I know you did this project. What do you call these? Please chat with me and tell me the answer. What do you call this? That we used to learn pneumatics and hydraulics in term 1. They are called what? We call them syringes. These are the syringes that the doctors use, okay? And then I have a question for you. This has some fluid inside. You can see there's a liquid inside there. Now, question is this a hydraulic or a pneumatic system? Tell me why you say so. Is it a pneumatic or hydraulic system? Is it a pneumatic or hydraulic system? Hydra means water. Hydra means water. So if we say it's a hydraulic system, it means that that system has some liquid. In pneumatics and hydraulics, we call this hydraulic fluid. So this is a hydraulic system because it has hydraulic fluid. Okay? Pneumatic are systems that use gas or air. So this is a hydraulic system because it has hydraulic fluid. Okay? Now, I want you to understand this. Okay, we said we use syringes to learn pneumatics and hydraulics in class in term 1. Now, this is the plunger of the syringe. This, we call it the plunger. Now, we have input and output. It's what we called when we were doing levers, effort. So our process starts whenever we have input, that is where our process starts, okay? The input. Now, we have this syringe, a smaller syringe, and a bigger syringe. We want to see the transfer of force between these two syringes. This one is the input. So where in hydraulics and pneumatics, where the input is, the input cylinder, we call this the input cylinder. We don't just call it a syringe now because we are modeling a pneumatic system. So we call this a cylinder. The input cylinder is called the master cylinder or the driver cylinder. So this is the input stroke master or driver. This is the output stroke slave cylinder. This is the master, this is the slave. Slave cylinder or driven cylinder. The output. We have the output on the slave cylinder. Now, this one is the master cylinder. When I press down here, the plunger, when I press down the plunger, the hydraulic fluid will move to the slave cylinder. Here we have changed, we have reversed the roles. The big cylinder is the master cylinder, and this one is now the slave cylinder. We have the input here and we have the output here. We have studied these systems now, system A and system B, and you understand them now. Now answer the questions that are based on the illustrations now. Let's assume that the bigger syringe is double the size of the smaller one. Both the cylinders have fluid, so they are what systems? Because they have fluid. What do we call a system that has fluid? What do we call it? Hydraulic. It's a hydraulic system because they have fluid. In system A, the smaller cylinder is the driver cylinder or the master cylinder. In system A, you could press down the plunger of the input cylinder for 1 centimeter. If you could press down the plunger of the input cylinder for 1 centimeter, and the output cylinder would move how many centimeters? System A. Let's go back to system A. System A, I press down the plunger for 1 centimeter. This one is double the size of this one. If I press down the plunger for 1 centimeter, the hydraulic fluid will move for how many centimeters here? Who can tell me? If I move down the plunger for 1 centimeter, this, in system A, okay. If the input cylinder, if this is the input, if I press down the plunger here and I move 1 centimeter, how many centimeters will the output be? This is the master, this is the slave. I move 1 centimeter here. What will be the movement here? It will be 0.5 centimeter, not 2 centimeters. Because this one, this master cylinder is half the size of this. So it will be 0.5 centimeter, 0.5 centimeters. Correct. Angelina? Correct. Okay. And on this side, if I reverse the roles, if I make this one the input and I move 1 centimeter, what will be the movement of the hydraulic fluid on this? Obviously, it will be 2 centimeters because this one is double the size of the other. Okay. In system B, if you press the plunger of the cylinder for 2 centimeters, the output cylinder would move. System B, the master cylinder is double the size of this one. If I move this one 2 centimeters, so it means this one will move 4 centimeters. Okay. What can you conclude about the force transfer in system A and system B? I'll give you 2 minutes to think about that and answer me. The movement of force, because we have seen that the hydraulic fluid will move in a way that is proportional to the size of the cylinder. Let us look at the answers. Okay, we gave these answers. The last one, in a hydraulic system where the smaller cylinder is an input, driver, or master cylinder, like in system A, the output is reduced. When you make a master cylinder the small cylinder, the output will be reduced. Okay? Where the bigger cylinder is the driver, the output force is increased. Now, in a system, the movement, the distance, the distance is increased. Let me explain this so you understand it. Here, if this is the input, the distance will be decreased here. If I move 1 centimeter, the distance will be decreased. It will be 0.5. But the force is greater. The force is multiplied because it is now spread on a wider surface. Okay, the area is wider. So you will see when you later learn about lifting mechanisms, you will see that for a small input, the force will be greater to lift a heavy object because the force is multiplied because of the larger area of the output cylinder. I don't know if you remember this. Do you remember this? Who can remember this? Did you do it? It is Jaws of Life. You did it in term 1. Yeah, Jaws of Life. I hope you all did it in your schools. Okay? Now, because you did Jaws of Life was your term 1 practical assessment project. Okay, I want you to answer the following questions based on Jaws of Life, the video that you just saw. Now, which of the following can be compressed? Air, sand, or water? Which is it that can be compressed? Give me the correct answer. You cannot compress water. That's why we have hydraulic systems. You can compress air because you have a compressor. You know that machine we call a compressor? Yes, you can compress air. Just imagine if you could compress water. Now, our hydraulic systems would not really function well. Just imagine if you could compress water. Now, if I am applying force on this plunger and I want to move this hydraulic fluid towards the output cylinder, instead of moving up the plunger of the output cylinder, what would the water do? It would compress. So it would make our systems it would make our systems very hard. The hydraulic systems, they wouldn't be that efficient. In the industrial world, they find it very easy to operate with hydraulic systems, especially in things like lifting mechanisms. If you want to lift something, imagine if I put a weight on here, if I put a weight on this output cylinder, and then I apply force on the plunger. You know what will happen? This plunger of the output cylinder would not go up. Here, it would not go up because if this is a lifting mechanism, maybe I put a car here, I want to lift the car, it wouldn't go up. The weight of the car would compress the hydraulic fluid, then the car wouldn't go up. So for a good lifting mechanism, we need a hydraulic system because you cannot compress water. I will apply force on the plunger of the input cylinder, and then the hydraulic fluid will go right through the connecting tube and lift the plunger of the output cylinder. And the force would be multiplied. And then what would happen? The car would be lifted up. You see? That's important. That's very important for us to remember about hydraulic systems. Okay. Give an example, or I've given you an example, okay, of the compressor and a hydraulic system, like a car lift, okay? When we connect two syringes to a tube, we call it a syringe system. When the syringes are filled with air, we call the system a pneumatic system. Water or oil is used in a hydraulic or pneumatic system. The correct answer would be hydraulic. I've already given you an answer before. In the video, the syringe, which is pushed by the finger in the syringe, the syringe which is pushed by the finger, in other words, the input syringe, the input syringe is called the master or a slave cylinder, which is the correct answer. It is the master cylinder because that is where the input is. The master or slave cylinder is also called the driven cylinder, which is called the driven cylinder. Which syringe is also called the driven cylinder? The slave cylinder is called the driven cylinder. The input is on the driver cylinder. The output is on the driven cylinder. The system in the video is a hydraulic or a pneumatic one? Is the system on the video a pneumatic or a hydraulic one? It's a pneumatic system because we didn't see any hydraulic fluid. Very correct. Mian and Angelina, it's a pneumatic system because it uses air. We didn't see any hydraulic fluid. Okay, we have given the reason. Thank you very much for attending this class. I hope that gave you a revision of our term 1, mechanical systems and control. Any questions? Do you have any questions for me? Thank you very much. Have a lovely evening.